This is the notorious geometry question that made it in the news headlines. A lot of people were left scratching their heads with this last question on the GCSE 2022 Maths Paper 1 from Edexcel. It looks impossible when you first assess it. However, once broken down, there are various ways to calculate it. Okay, the question says the diagram is made of 3 circles, each of radius 4 centimeters, the centers of A, B, and C such that ABC is a straight line. Work out the total area of the 2 shaded regions and give your answer in terms of pi. Okay, so AB is equal to BC, and we are required to calculate the area of the blue shaded region. Okay, so here we have an intersection point of the 2 circles. If we draw a line to the center, notice it is the radius given as 4 centimeters. If we do the same and draw a radius from the middle circle to the edge of the circle, it is also 4, and again here it is also 4. Notice an equilateral triangle is created. We can repeat the same process below, on here, and there too. In these equilateral triangles, all angles are equal. They are 60 degrees. We can call these areas here segments, and we can also calculate the area of the segments. Before we do that, let's recognize that this region here, it is a sector. It is a sector with radius of 4. So to calculate the area of a segment, it is the area of a sector minus the area of a triangle. Let's calculate the area of a sector. It is simply the angle divided by 360 times pi r squared. The angle in our sector is 60 degrees, so this will simplify to 60 divided by 360. Our radius in our sector is 4, so this will simplify to pi 4 squared. Pi 4 squared, it is 16 pi. Let's simplify this a bit. So 6 into 36, it is 6. 6 divided by 2, it is 3. 16 divided by 2, it is 8. So the area of a sector, it is 8 pi divided by 3. Next. For the area of a triangle, there are various ways to calculate it, and here are some ways. So you could use half AB times sin of an angle, or you could use half base times height. If you choose to use half AB times sin of an angle, let's use this other triangle. If we now draw a perpendicular line in this equilateral triangle, not only it divides the angle and the side equally, but we do also end up with special 30, 60 degree triangles. This will help us to find sin of 60 later on. If we go back to the area of a triangle, we do know what A is, it is 4. We do know what B is, it is 4. So half times 4 times 4 times sin of 60. If we go back in our triangle, sin of 60, it is equal to square root of 3 divided by 2. If we substitute sin of 60 by square root of 3 divided by 2, all of this will simplify to 4 square root of 3. So this is the area of one triangle. The area of all 4 triangles, it is simply 4 times 4 square root of 3, which simplify to 16 square root of 3. Next, if we go back to the area of the segment, we said it is the area of a sector, which we have here, minus the area of a triangle, which we also now have here. So this will give us 8 pi over 3 minus 4 square root of 3. We do have, though, 8 segments. So the area of all 8 segments, it is simply 8 times 8 pi over 3 minus 4 square root of 3. So this will simplify to 64 pi over 3 minus 32 square root of 3. So If I now draw your attention to the middle circle here with the blue shaded region that we need area for, we can calculate the area of a circle first. So the area of a circle, it is simply pi times radius squared. Our radius is 4, so pi times 4 squared will give us 16 pi. So therefore, the area of the blue shaded region, it is the area of the circle, which we know is 16 pi, minus the area of the 8 segments that we calculated the area there earlier. So minus 64 pi divided by 3 minus 32 square root of 3, minus the area of all 4 triangles, 16 square root of 3. So this will all simplify to 16 square root of 3 minus 16 pi over 3. How exciting was that?